Welcome to the Oxygen Alliance YouTube channel, where we bring you videos on installation, maintenance, and various trainings on oxygen equipment and devices. If you have comments and or questions, drop them in the comment section below or write to us info@oxygenalliance.org. Remember to like our videos, subscribe to our channel, and hit the notification bell.
Hello everyone, and thank you for joining our today's podcast talk brought to you by the Oxygen Alliance. My name is Diamedica. I am a biomedical engineer for Oxygen Alliance, and I'm excited to be your host today. So this is a video meeting where we'll be discussing about the Diamedica baby CPAP. And if you want to be on our emailing list and get notifications for upcoming webinars or events for the Oxygen Alliance, may you please type your email in the chat as well. So today we have a very interactive session from Diamedica, and we'll be diving deep into the Diamedica baby CPAP machine, like I've said, and this will be a live demonstration presented by our special guest, who is none other than John Meek, the Managing Director for Diamedica. He will take us through the evolution, operation, as well as the maintenance of Diamedica CPAP machines. So please stay with us, and I'd like to encourage everyone to take notes as we look forward to hear your comments as well as your questions at the end of the presentation. So without wasting much of your time, I'll now hand it over to John Meek to take us through the presentation. Over to you, John.
Thank you very much. Good afternoon, everyone. My name is John Meek from Diamedica. So as you say then, today I'm going to give you an overview on the evolution of baby CPAP, how we started it and where it's come from, right the way through to today's models and versions we have out in the field. So where did the Diamedica baby CPAP first begin? So it was designed initially to provide safe bubble CPAP in areas that tended to not have the availability to provide safe CPAP. Oxygen supply, air supply was an issue, humidification, and all these factors which are so greatly needed in CPAP. Our first model, so we decided we needed to design a CPAP which produced its own oxygen, which eliminated the use of oxygen cylinders, which was heavily relied upon for most CPAPs, and also a safe control of bubble CPAP. So initially we started with an oxygen concentrator from AirSet, which you might be able to see on your slide at the moment. So on the left-hand side is the standard oxygen concentrator, widely used around Africa for many, many years, and well renowned for being reliable. So we had to work through it, to go through to find out how we can actually design and utilize this CPAP. So on our CPAP, as you can see, we make many modifications inside. So on the side here, we have our CPAP, which is the AirSet. This is our first model we did. This one's got slightly few modifications compared to the initial one that we started with. So we had to control the amount of air being flowed into the CPAP, and we also had to control the amount of oxygen going through and controlling the bubble pressure. The CPAP circuit side of things, I will go through on the newer version, but going through on this version here. So we supplied oxygen. So if I can just open the side to show you very simply what we have to do. So on the first model, we had different regulators. So we want to regulate and control the flow and pressure. So we're using the compressor inside the CPAP, which is using to generate the oxygen through the sieve beds. We're actually taking a tap off from the compressor, but it's going through a regulator. This is the latest version of the regulator to maintain a steady flow of up to 10 litres a minute of oxygen. So we're taking off the compressor, but more importantly, coming through, what we realized going through time, and you'll see it on the new one, is we had to fit a water trap, a self-draining water trap, because in the humidity and environments these are going to be working in, air generated from compressor produces a lot of moisture. So all the moisture going through, the last thing we want to do is put it through to the flow meter. Humidification is obviously key, which is good. So we're using air which is already humidified, but the extra moisture, we have to put in a water trap to remove any of that moisture, so you don't actually get a physical amount of moisture in the flow meter build-up to the patient. Also, what's very important is we have to filter all of our equipment. So in the side here, we have everything fitted in. So we have our flow regulator, and then going through the regulator, everything fits in the side here. We have a medical HEPA filter. So this HEPA filter takes away any particles, any bad things that come through from the compressor, and remove it in this final bacteria filter, making it safe to be delivered through to patients. So it's a very simple tap off from the compressor, water trap, regulator, through the HEPA filter, and then through to the flow meter, utilizing every part of the machine to help it run. In the option side, again, we used to have different flow regulators in this side. We now do not have any flow regulators because you don't want to control the flow. It's all controlled now from the pressure being derived inside, which is 20 psi. We still have a HEPA filter, for any final bacteria filter going back to the patient. You want to make sure we had a HEPA filter to make sure it's clean and functioning correctly. When we have a humidifier bottle fitted at the front, as you can see on the picture on the right, so we can humidify all of the oxygen air mixture going to the patient. We have put here a little grill with a hole going down above the compressor. So what this is doing is it's actually using its own heat generated from inside and warming the humidifier bottle. So this was the first level that we got to, where the heat was coming up and it was warming the bottle, providing extra humidification to the delivery to the patient, which is really, really important. Going forward, though, as you'll see on the next model, we've improved the way we use the heat generated and how we can control the heat. And we've learned so much along the way from the first model that we had here, going forward, right the way through to the other model that we have on the side. So everything has been improved over the years. This one was around for about 4 years, and each year we had different improvements as we learned the way things work and what was more reliable and what worked very well. Right the way through, we constantly did improvements. We used to have an accumulator tank fitted in here to control the flow, to make sure the airflow meter was steady, so you had a steady output. And now we've gone to a different regulator, which now eliminates the need for an oxygen air tank to steady the flow. So everything has been designed to ensure a safe CPAP flow is delivered. I won't go too much into this because we'll show you going forward. On the back, we have a simple mixing chart, but I'll show you on the slide in a minute as we go forward. So this was the AirSet one. So this is the one we first had our derived CPAP. And then moving from this one, we have side by side, we have the new, I say the new, it's been around now for about 6 years. We've evolved to a CPAP 20 and a CPAP 10 using a different concentrator to generate CPAP, but it means we could have 2 different models to give a variation for the requirements for everyone. So this one now will come as a model, a CPAP 10 or a CPAP 20, and this one just have one range, which some of them used to be an 8 litre, but now they only come as a 10 litre as they stop making these CPAPs. And this one I'll go through in more depth for maintenance and things as we go forward, but just to show the comparison of how they changed and evolved going through time. So, and the one thing is, the reason why we picked these ones was because we required low maintenance CPAP, and safe, controllable, and they both provide great functions of that. This is, like I say, the first one that we had in our products range. So just so you know how, quickly before it goes through, on the slide, there'll be a slide showing how the CPAP is designed and how it's set up. So when I just spoke through then, it shows you step by step how it actually goes through the muffler to the compressor, and then how we tap off the compressor. It goes one way through the sieve beds up through, which I'll go through as we open up the other one more in depth and go through, and how it goes through its filters, pressure regulator, right the way through to the option there, flow meters. And on the mixing chart, I know it's quite hard to see in here, but there is a slide with the mixing chart on it. And again, I'll go through that, showing a bit more, but it's a very simple and easy to use chart, which across the top is your airflow meter. So in the gray, it says 0 to 10, which is showing you what setting to set the airflow meter to, and the option down the left-hand side from 1 to 10. And if you join the lines together, running across, and where you meet in the middle is what percentage you're delivering. And then the combined flow rate of the two flows is the flow rate you're delivering. So whether it's high flows or low flows. And again, once I go into the other machine, we'll cover that a little bit more to make sure everyone understands how the simple ways that we've designed to make it really user-friendly. So that's it on the evolution bit. This was the first one, and I'll move across for the main part of the presentation on to the developers concentrator. Okay, so as I said before, we've designed our CPAP to be to generate its own oxygen and medical air. Going forward, we have two ranges. We have a CPAP 10 that does has two flow meters from 0 to 5, so you can generate a maximum of 10 liters a minute, 5 of air and 5 of oxygen. We also then have a CPAP 20, so it provides 10 liters of air and 10 liters of oxygen, giving a combined flow rate of 20 liters a minute. And the reason we've done this is so that it gives you a range of different weights you can use it on. On a CPAP 10 is a maximum of up to 5 kilos the CPAP can be used on. On a CPAP 20, the maximum weight can be used up to 20 kilograms. So it gives you a much broader range on the CPAP 20, but also it just gives people that versatility depending what they require, which is really important to us to increase our range availability. So on these, they have their own built-in alarms, built-in oxygen lights and everything. So then they have their own self-test, which is really important. So we have on the front here, we have a maintenance alarm, a low oxygen light, a green oxygen light, so it tells you when everything's good. And we have an hours counter for maintenance, but also how many hours it's run by. We have a circuit breaker for any power fluctuations, on-off switch, and a common gas outlet for the oxygen and air, which we connect onto it. So I've said that we have a circuit breaker. As we know, we sell and have worked in these areas for a long time. So what this means is we have learned that power is one of the biggest issues we were struggling with on all our products, and as I've come across with many medical products. So on everything we have fit an external voltage protector. So this provides voltage protection within a certain range of voltage. So if it exceeds 250 volts or goes below 190 volts, which is what this needs to run at 190 is the minimum, it will cut out. And what this does is it cuts out on, and there's indicator lights on the back, but then it doesn't come straight back on. It analyzes the voltage for 10 seconds, once it's within that range again, and then allows it back in. And the good thing about this is, even though it cuts the machine out, it protects the circuitry. And if you don't have something like this, if the power affects the internal electronics, you lose the machine completely. So it was really important to put this on. It does, again, a self-test. If I plug this in, what you'll see all 3 lights illuminate on the machine, and then you'll see it'll go orange. And this orange means it's analyzing the voltage for that 10 seconds, and then it will go green. And that means it's safe to use. So if I plug it in, it's now orange, which is indicating the voltage is good, but it's just analyzing it for that 10 seconds to ensure it's steady. And now it's gone green. So these are very simple. They just hook onto the back of the machine, like so, but they should always remain with the machine to provide electronic protection for the device. So before using it, I said before, this is a low maintenance machine, a daily low maintenance. General checks before you use the machine are the circuitry checks, but in the back here, we just have 1 filter. So this is the only thing that needs to be checked. I would suggest before every use, but it's down to the user, depending on how clean the environment is, to check to make sure that this is clean and not obstructed before use. If it is, it should be washed and cleaned in soapy water, but must be thoroughly dried before replacing. So we always send them out with a spare one because we know they can use it and then take the one away, replace it with a replacement, and clean the other one and allow it to dry fully. If you don't keep this one clean, there is another filter in the back here. This one cannot be cleaned, it has to be replaced. So it just shows the importance of maintaining this one to protect the filter inside. And I'll go through routine maintenance and how long these should be checked or how long they should last going forward when I get into the maintenance. So on the machine, because this generates its own oxygen, what we need to make sure, first of all, is it has to be at a safe level producing its oxygen before we actually connect it to a patient. So the pre-start checks, before we connect up the circuit and everything, we need to make sure we go through each check and make sure everything's okay. When I switch this on, the self-check means all 3 lights will illuminate and the alarm will sound. And this is really key, because if the alarm doesn't sound or the lights don't come on, it does mean there's a fault with the machine and should be taken away to a technical department or contact ourselves for any further information. But if it doesn't alarm, it means the alarms won't alarm if there is an issue with it. So it should not be used. So when I switch this on, what will happen is all 3 lights will come on, the alarm will sound for 1 second, and then what we'll see is we'll see the low oxygen light come on. And this will take approximately 5 minutes, maybe a bit less, for the green light to come on. And that is the key light we want to see to say the light's green, we're good to use the machine. Okay, so I'll switch the machine on. All lights come on and the alarm sounds. The low oxygen light is now on. So we know it's going to take a little while for it to build up and generate its own oxygen. So it shouldn't be used until the light goes green. So one check I'll do once this is warming up, we can check our flows are reach the maximum and then set them back down, same as the air. It's really important because this generates now its own oxygen and air. It uses something called sieve beds to generate the oxygen. As it goes through the sieve beds, it absorbs all the carbon dioxide, nitrogen, everything in the atmosphere that's not required, apart from argon and allows 95% out. Because it's generating its own oxygen and absorbing, and everything is calculated through the sieve beds, the flow has a maximum rate. If you exceed this above the maximum, the machine will deteriorate a lot faster than it should do. The sieve bed should not need replacing at least up until 5, maybe 10,000 hours, depending on the liters per minute used. If you overuse the oxygen, you will deteriorate the sieve beds a lot faster. And that's one of the biggest pickups that I come across myself. That people think you need high flows above and beyond 10, when it's not that that's generating the CPAP, it's the pressure, which I'll show you in a minute. These are just creating the oxygen air mix at the flow required. Same on the air. Please don't exceed 10 litres a minute. It's there and designed to run 10 litres a minute as a maximum. As you can see, that was quite quick. The green light has now come on, which means she is safe to use. So that's one of your pre-start checks before using it. Setting up the machine. I'll come back to when it's running in a second. And now what I'll do is I'll set up the circuits. So what we want to do is we want to ensure safe CPAP is supplied. So what we have, first of all, as we said, we have a humidifier bottle to provide humidification, which is really important to provide warm oxygen and air mixture with humidification, not dry, a dry mixture. You can see in the bottom, actually, underneath, there was a grill. There is a slight flow rate of warming air underneath, which will warm the humidifier bottle. And on the air set, it's not controlled. On this one, we've redesigned it to improve the warming by controlling the flow onto the bottom of the humidifier bottle, allowing the flow rate to ensure the warming to the correct level, between 31 and 36 degrees. On here, with a humidifier bottle, it's fitted. Be careful. The plastic fitting doesn't need to be done up too tight, otherwise it can break. On the front here, the humidifier bottle has a minimum and a maximum. Do not overfill the humidifier bottle on any of the machines, because if you do, what happens is moisture will flow out into the circuit, and then you'll affect the pressure and flow going into that circuit if the moisture becomes too much. So ensure that it's not filled above the maximum, depending what flow humidifier bottle you have fitted. So on here, the bottle must only be filled with dealing water or water that's been boiled or allowed to cool. You cannot just use tap water, as you will provide bacteria or anything in that water into the patient and can cause illnesses further to what they've got. So coming out of the water trap, out of the humidifier bottle, we do fit anyway a water trap. So we fit a water trap to ensure that any moisture that does flow over from the humidifier bottle is caught in this water trap. This is a self-sealing water trap. So if it's in circuit and you disconnect to empty the water, it bypasses the water, the actual drain, and it still passes the oxygen through and air mixture through. So you don't have to switch it off or switch it on when emptying or filling, which means really important. You don't want to keep stopping and starting the machine when it's on CPAP, providing it to a patient. This just connects on, hold the bottle, fits onto the side, as so. And it works in both ways. It doesn't have to be a direct way. That's the humidifier bottle on the side. So on the other side, which I'll show you in a second, this is what generates the pressure. This is a bubble bottle. This bubble bottle provides safe bubble CPAP at an accurate pressure and flow to the patient. What we have on here is we have a simple dial from 0 to 10. And what that's doing is it's allowing deeper, the higher you go, the deeper it goes. And what that's doing is the deeper it goes, the more pressure you have to create to generate bubbles. This is why it's called a bubble CPAP. So if it doesn't bubble, you're not providing that pressure of CPAP. And I'll show you that in a second. What's also really important is knowing that the water level is the correct level. So when you fill this, this must be at the correct level. There's a dotted line. If you overfill it, you'll be providing higher pressure than what you set. If you underfill it, you'll be providing lower pressure. So it's really important just to make sure you fill it to the correct level when it's set to 0, and then you'll be providing the correct level of CPAP to the patient. Excuse me. So the bubble bottle will fit on the side of the machine like so. Okay, so nice and simply slots onto the side there. So going forward from this, we have our circuitry. So we have an inspiratory and an expiratory tubing. The inspiratory is coming from the CPAP, and this is connected to the water trap. And then we have expiratory tubing, which is then connected to the top of the bubble bottle. Nothing needs to be pushed too hard, it fits correctly. So then we have our inspiratory and expiratory fitted. And I'll show you why this is important now. So going forward from there, we have our nasal cannula kits. And we have you get various sizes. They can be cut to adjust the size depending on the width of the baby's head. So they've got barbed grills and you can adjust them. Same as the nasal prongs, you can actually cut and adjust the lengths to the correct depth you require. Once they are fitted, you can see there's two differences on each elbow here. One has a lure lock sampling line connector and the other one doesn't. So the sampling line connector, if you have it, is a CO2 sampling line, and it must be connected on the expiratory tube. If it's connected on the inspiratory, then what you'll have is you'll have fresh gas flow going over it, and you won't be reading any CO2. So it needs to be on the expiratory side. Fitted on these, so this is the inspiratory. It's connected on that side, and the expiratory, sorry, on the other side. Inspiratory without, expiratory with the lure lock connector. Okay, so if I run the machine again, it's already been generating oxygen, so it'll take maybe 10, 20 seconds to build up the pressure. So what I'll do is we're going to look to set the pressure and flow rates as required. So I'm just going to set 5 and 5 on my flow meters to give about 60%, which tells me on my chart, or 58% oxygen, and I'll set the bubble bottle to 5 centimeters of water. So it's really important when it's running. So we've set the flow rates to require what you require. I know the light's still orange. It'll turn very quickly to green because we've just been running it. And use the center of the ball, your diameter to read the machine. So you can see that it's bubbling in here, and it's warming. Once it warms up, after it was left it running initially, it will be using the warm air to warm the humidifier. Inside as well, we do warm the oxygen already before it comes out of the actual common gas outlet, the oxygen there. So we internally warm as well to provide the temperature warming of the machine. So we have the cannula fitted at the moment. So you can see we have bubbles in the bubble bottle. As you can see, if you don't have any bubbles in the bubble bottle, you're not generating the pressure. And this doesn't mean the flow rates have to be higher. Because increasing the flow rates, this is where the issue goes. People think they have to go higher and higher. It tends to mean you either haven't got the cannula fitted correctly, the right size, or you have a leak. So if you fix that leak, the bubbles are generated. But it also means the cannula might not be fitted correctly. So if I reduce the flows, as you can see, there's no generating any pressure in the bubble bottle. So CPAP is not being provided to the level that we are set it to. If I include the cannula, you'll see bubbles are now being generated. And it's not because there's no leak, it just means you haven't got a good connection on the nasal prongs for the infants. So it's really important, instead of just increasing the flows until you get bubbles, you need to make sure that the actual nasal prongs are fitted correctly as well. Again, you said it's what you require. So, like I said, 5 and 5 we're setting ours on. And that's generating about 60% FiO2 to the patient and 5 centimeters of water pressure, which we're generating in the bubble bottle. So that's how to set up and use the CPAP. I will just go see if we can go through the mixing chart again to give you another look. So we set to 5 and 5. So as I said before, the airflow meter, I set to 5 meters on the airflow meter and 5 meters on the oxygen. If you meet in the middle, it comes to 58%, and that's 10 liters a minute at 58%. If you need higher flows or lower flows, you can increase, to 9 and 9, or in lower flows if you're generating the pressure, depending what weight you're going for, 3 and 3. You see, you can still generate different pressures and flows at different safe FiO2 levels, which is really important, but it makes it really easy to understand how to set. So that's how to set up the CPAP and the different flow rates on the machine. So what I'm going to do now is we'll switch the machine off and we'll go through some general and basic maintenance of the machine. So this machine has been designed to be low maintenance, have very low running costs, but also easy to use. Okay, so the first step for removing the cover. We have 2 screws in the top, 2 screws in each side, and 2 at the bottom. I will remove I'm going to remove each screw. Okay, so once all the screws are removed, so the first cover, you can just pull gently away and it will come completely away without anything connected. The front will not do the same. Okay, so this is the designed machine, as you can see in the front. I will talk you through the air side first and then go through the oxygen side going forward. From this side, so we have a compressor generating the air for the oxygen and for the air. Coming off, we take off from the air. So on the air side, we use the warm air generated from the compressor, which is hot, and we control the speed. We take the tap off. This goes up to the humidifier, up to below the humidifier bottle. So we're controlling the speed of warm air being pushed and forced up to warm the humidifier bottle. And this allows a steady flow of warm air, warming it to the correct temperature. So this is set to no more than 6 litres a minute. So this is what we set this to. Coming off there, going down, like we had on the air set, it goes to a water trap. If you're trying to generate air from a compressor in environments high humidity, you're going to get moisture in there. So it's really important. And these are self-draining water traps, like I said before. So they will fill up to the white disc. So if I've just got one here. So on here, you'll have a white disc. As it fills up, if it gets above the disc, it has failed. But once it gets to a certain level, it will lift the disc and allow the moisture under pressure to dissipate. So you won't see the moisture on the floor because it comes out as a mist. But once it gets up, it will automatically drain out of here. And you will see this condensate pretty quickly due to the temperature of these environments they work in, but they will remove a lot of moisture from the machines. And if you need to, you can unscrew and disconnect, and you have a filter in the bottom and the little piece that lifts in the bottom there. But very simple, auto draining. You should never have to take these out as they will auto drain on their own. They have got a direction of flow. So if you ever take any of them out, it only works in one direction. So if you don't have it going the right direction, it will not remove moisture, and it will put moisture, leave the moisture in the system, which will affect moisture in the flow meter. Coming from the water trap, so we've moved the moisture, we come up over the top to a pressure regulator. So this is what's maintaining the safe pressure, but also maintaining a steady flow. So if you don't, this is a just set in the factory. The outlet pressure is set to 0.55 of a bar. If you have it too high or too low, if you set it too high, the moisture will not have time to be removed from the water trap, and also will fluctuate on the airflow meter. So we want it to be a steady flow output. So this regulator needs to be set to 0.55 of a bar, which will mean you get no moisture coming from the flow meter, and also you get a steady flow on the flow meter. I'm just going to remove the front panel slightly. So we have a screw in the front, which will have to be removed. And you have to be a lot more careful with this one because there's tubes connected and electrical wires at the front. And then we have 2 screws at the back. So there's only 3 screws holding this one on. Okay, so on this one, if I just gently pull it. So I'm going to apart now. Excuse me. There we go. So they do clip into place. Just needs to, you need to be careful now because it is linked a lot with tubes to the flow meters in the front. So on this side here, we have carrying on from your air regulator. It then goes through your HEPA filter. So these are your fine bacteria filters, removing any fine particles, anything that's supplied for the patient. Really important. These will probably need to be replaced every 18 months, maybe 24 months. They will last longer if the environment is a lot cleaner or you maintain your filters a lot more. They are only one directional. So there is an in written on it. If you put them the opposite way, they will become a barrier and then they will not work. So you need to ensure direction of flow is correct. When these are gray, that's fine. So when you first start running, they will go gray. When they go black, it means they're starting to become a barrier and they need to be replaced. But like I say, these should be 18 months to 2 years minimum, these should be fine to use. Again, it's all down to the filter and the maintenance before that. So once that comes through from your HEPA filter, it goes into the back. Through to your flow meter. And then it goes into the common gas outlet in the middle. Really simple, but really effective on that side. Going through your option side. Okay, so we come out of the compressor here, through a filter, down into the back here, which I can't quite show you, which is a rotary valve. So the rotary valve is all it does is cycle between these two silver sieve beds. These sieve beds are what generate your oxygen, remove nitrogen and carbon dioxide and everything out of the air and leave 95% oxygen. Your rotary valve is switching between the two. So when one charges, the other one discharges. And same again, and it's a continuous cycle. So every time they discharge, they regenerate back to new as they would. These are designed to remove moisture as well, to take out, but these are what if you use too much flow, these are what's going to be ruined going forward. So if you have too much flow, you will lose a lot of life in your sieve beds, which are really important parts of the machine, and you cannot exceed that flow, otherwise they will be damaged. Coming out of your sieve beds, it goes into accumulator tank in the side, set with a pressure regulator of 20 psi. So the output pressure is 20 psi. That's the maximum. This is what you want it set to, but also you don't want it coming through your sieve beds any faster than the recommended set flow rates, because you'll deteriorate your sieve beds again. So these should never be adjusted because they're preset and locked in. Once it comes out of your accumulator tank, it then goes through your circuit board, which has got at the top there is your analyzer cell built into your board, which are long life cells. And that was another thing that was really important. We needed to use a long life cell rather than ones you have to replace every 3 to 6 months. Again, reducing the cost of the overall use running of the machine. Comes out of your circuit board through another HEPA filter. So the same as the air, that we're going the other way now, through down through to the compressor. And this is what we do here. So there's a coil around a metal pipe which is warmed from the compressor. So we're using these coils as they spin around, letting the air through. And what's happening is it's warming the oxygen, because the oxygen is cold with no moisture. Obviously, we want to ensure we warm the oxygen as well. So it's warming it and then throwing it back through a non-return valve. And that goes directly all the way to your flow meter on the front. So that is on the CPAP side. And then finally, one thing left to show you. So on the two CPAPs, which is really, really important, is we have the filters, which I said about in the back here. So we have one for a CPAP 10 and one for a CPAP 20. The CPAP 10 only has one small inlet port on the top. The CPAP 20, which required a lot more draw of air, has 2 inlet ports on the bottom. So you need to ensure if you're going to use new filters, you make sure you get the right ones. Otherwise, if you try using this one on CPAP 20, the machine will draw so much harder, work a lot harder, and the compressor will only last before it needs a service kit. But that's everything on there. Okay, well, that's everything covered on the CPAP 10 and CPAP 20, how we've gone through the variations of models we've done and designed, and how we first started, really, to what made us want to generate something to produce it, and hopefully a little bit of maintenance and insight to what you need to do to check and how it worked internally and what things are doing and why we've used things that we have. Thank you for your time. If anyone's got any questions, please be much appreciated.
Thank you very much, John, for that wonderful presentation. I believe, my fellow engineers, you have really learned a lot. And for those who missed today's talk, sorry for you guys. So reaching this point, we'll take questions. But then before, if you have any question, please raise your hand and we'll give you a chance to speak, or you can just type in the chat. But then before we go to that, I've seen some questions in the chat, so I'll just read them through. There were a few people who asked questions. For example, the first person is Nancy. Nancy Leon, at some point, raise your hand. I don't know if she had something to say, but then there's a question from Robin Richards. He is asking, did you say it lasts 10,000 hours in a normal use, the baby CPAP? He wanted clarity on the number of hours that it has to work before, when it's in normal use.
Yep. So the SIV beds are what normally is 5,000 hours. So the rest of the maintenance will be every 24 months for the filters to check. But the external one needs to be checked every time before use. The 5,000 to 10,000 hours is the SIV beds. And so these will need to be replaced when the orange light comes on. But that can be determined by the flow rate. So if people are only using 3-4 litres a minute, the SIV bed will last a lot longer than if people are using 9 or 10 litres a minute. It will last a lot less. So it all depends on the demand from the actual user themselves will determine, but the range for the machine to last on the SIV beds is between 5,000 and 10,000 hours.
All right, thank you very much for that answer. So we also have two questions from Dominic Mabanje. The first question is saying, why is the humidifier bottle heated and where does this heat come from? May you please clarify on the science behind heating the bottle? And another question is, on the air-safe CPAP, is there any reason for using a maximum flow of 16 liters per minute? Because we know that babies wouldn't need all that flow. So may you also help us in answering those two questions? If you need clarity, please let me know. Sure. Over to you.
Yeah, no, absolutely. So the humidifier bottle is warmed. Absolutely. You can't use, or you can use, but you shouldn't use cold water. So you want to warm the humidifier bottle because that adds humidification to the infant. So we're trying to add humidification. The colder the bottle, the less humidification is going to come from that bottle, or less oxygen there is going to be humidified. So we warm it to a certain degrees to allow about 80% humidification, but that depending on local temperature, but it's adding humidification, which is really important. So if you don't warm it, you're not going to add extra humidification. You'll be adding very little into the machine. Most of the machines have temperature controlled ones. We use the heat generated from the compressor. So it comes from, it's really hot now. We're using all the warmth from the compressor to be generated at a steady flow rate to warm the humidifier bottle itself. I hope that answers on the humidification one. For the CPAP one, I think you said 16 litres a minute. So on the old one, yes, it goes up to 16 litres a minute on the AirSet. One reason was because the concentrator produced 8 litres of oxygen. So we knew we could get 8 litres there to have a combined flow rate of 16. But also there's times when people do require higher flow rates. So we've done one to 10 litres a minute. And you'll be surprised how many people use quite high flow rates on their CPAPs. But we do have the range of a 5. And like I said before, the higher the flow rate means as well, means you can provide it to higher or higher weights at a time. So our CPAP 10, which is 5 litres of oxygen, 5 litres of air, is only up to 5 kilograms. But if you want to use it on smaller infants, up to 20 kilograms, that's when the higher flow rates are needed. So on the first one, we didn't have 2. So we just had the one model up to 16 litres. Now we've split it into 2. We have a lower weight and a higher weight one, which is CPAP 10 and 20.
All right, thank you very much for that, the answer. I hope, Dominic, your questions have been answered. So I can see a hand, there are two hands, but I'll first take the hand from Tamba Ali Pakima. Over to you. You can unmute yourself. Gladson, you also raised the hand. Can you please unmute yourself? All right. I guess they couldn't have unmuted themselves. Maybe they're out of the call. So there is also another question. Where can we find instructions on replacing all the spare parts and intervals that they need to be replaced? Where can we get instructions on replacing the spare parts, and what are the intervals at which we can replace them? This is a question coming from Robin Richards as well.
Absolutely, no, it's a great question. So for the manual side of it, we have a maintenance manual. The maintenance manual is available from ourselves. So anyone that requests it, they can request the manual, and it gives intervals. But again, for us, we stipulate different timing. So I would say 2 years for your filters, but it also, we know very much where we send things. It does depend on environment. So it's more the fact of when to check things. It more is if you check your filters, your flows. It's all in the manual with all the breakdown of 2-year checks, 3-year checks, and even down to a compressor service. But again, it all relays back to looking after the machine, and the filters and the flow rates will almost determine when you need to change things as well. But we do stipulate in the manual, if you check every 24 months for the filters to be replaced and checked. Sieve beds, we say when required, which from our experience is, as we said before, 5,000 to 10,000 hours, depending on demand, but it can be a lot less if it's not looked after. So it's really important to maintain the below 10 liters a minute. But you can get all this information on how to conduct all this maintenance in our manual, and we can provide it to anyone who requests it.
All right, thank you very much for that. I know there are a lot of questions in the chat, so I'll just also take these questions. There's a question from Clayton Sambo. She's saying, how is the temperature going to the humidifier bottle regulated? And also another question coming from Stanide saying, do these modifications affect the power consumption of the machine? Do these modifications affect the power consumption? And another question, how is the temperature going to the humidifier bottle regulated? Please take those questions.
Okay, so the first one about the humidifier bottle. So inside the machine, it has a built-in fan, which maintains the temperature overall of the machine. Exactly like a car, it maintains it at 90 degrees. In here, the fan's designed to remove at full speed enough temperature to maintain this about 87 degrees inside. So we designed the flow rate to be controlled to, as we tested the output of the warming of the bottle, to between 31 and 36 degrees. And again, that can change depending slightly by that much on the ambient air temperature. But the temperature inside the machine is maintained by the fan, which keeps it at a steady temperature, which means we can actually use that to control on the humidifier bottle. The other question was?
The other question was, does the modifications affect power consumption?
So, no, it doesn't. So the compressor runs at a certain speed. Because it's an AC compressor, it runs at one sole speed only. So what happens is, even if we're taking off air from the machine, it's still drawing the same amount, 670 watts, as it would do if we weren't using the machine. So it doesn't increase the power consumption for the CPAP compared to what it was with the concentrator.
Hello, Janet. I'm back. I was trying to work on my mic, but my mic is on now.
All right, you can go on.
Yes, I'm Tambali Pakimam from Sierra Leone.
Hello.
Yeah, nice. Nice to meet you all. Presently, we have 2 CPAP in our facility that's down. We are experiencing air leaking from the black holes behind. You just saw us. the yellow light is constantly on, alarming, and it works for short time. It go red. Yeah. So presently we are not using them to pack them.
Okay, I mean, I'm sorry to hear that. I mean, if you do have any issues, and that's anyone, I mean, we deal with issues all over the world. So if you WhatsApp me, we have a WhatsApp number which should be on the machine. If you WhatsApp that, we will come back directly to you that same day to help resolve the issue that you've got. So any issues that you have on the machine, we can figure out over WhatsApp from videos. Otherwise, if we don't know about them, we can't help fix them. So if you can send them through to the WhatsApp number on the machine, then we will go through it and help resolve it, because without just talking like this, I can't get a good understanding to what the actual issue might be, but we can resolve it, no problem.
Okay. I think you can share with us your WhatsApp number so that we can contact the service technician.
Absolutely. Yeah, no, that's no problem. Yeah, perfect. We'll share it at the end here, and then anyone can have it to if they have any questions.
Okay, then
Thank you very much.
Yeah, thank you.
Thank you, Tambali, for that. I'll take the last question in the chat, which is coming from Chadwick Godfrey, and this will be the last question for the day. I know you have a lot of questions, but you can just type them in the chat or you can contact us. So he is saying, is it very essential to attach the AVS to the machine, since from your explanation, the machine have the circuit breaker system? Is it very essential to attach the AVS to the machine, since from your explanation, the machine have the circuit breaker system? This is the last question. May you please take this one? Thank you.
Okay, no, thank you for the question. It is very essential. So these machines were designed probably to work in areas where power fluctuations were minimal, but they do have them. We know where we supply these machines, there's a lot of power fluctuations and the range is very high. So the trip circuit breaker will work to a certain level, but after many, many times of having high voltage given to the machine, it will provide wear and it will affect the machines. And that's from an engineer. I've worked on so many different pieces of equipment, and power is the biggest issue. From us now, putting the machine, having an ABS on the back has impacted no issues at all from supplying it with an ABS. So, but if you remove that ABS, you're opening it up to allow for damage. So over the years, we've been doing this now for many years. It is really important to keep the ABS on there, to keep the machine running, because we know the importance of these machines, but you must keep it on there to maintain the safety from the internal parts of the machine.
All right, thank you very much, John, Meek, and Kerry, for that wonderful presentation. I know our audience have learned a lot of things from you, and we hope to keep in touch, and they'll keep in touch with you as well on this. So this marks the end of the core. Thanks to Diamedica for the wonderful presentation, and I know this has been very educative. But then I know there are a lot of questions that you would like to ask. May you please type in your email in the chat so that we can reach out to you, or you can even reach out to us. And also for further questions, you can just email us at info@oxygenalliance.org. Thank you for attending. And those people who were asking about the video, we do share the video on our YouTube page. So definitely you will see it and you can watch it later for your needs in case you want to maintain or do something about it. Thank you very much. This is the end of the call. May you have a great day and a great evening as well. Thank you.